So looking at lesson 3.1, solving quadratics by factoring. Back in chapter 2, we did some solving by graphing. We looked for those roots or solutions or zeros. That's where we're headed here in chapter 3 as well. But today we're going to look at solving by factoring. So we have three different types of factoring. The first one would be finding a greatest common factor. And that typically is going to be your strategy when you have an equation that contains two monomials added together, or a binomial. Right, so I have, in this example, I have 4x squared plus 8x. And what I can do is I recognize they're both divisible by 4, right? The 4 from this 4x squared and this 8 from 8x are divisible by 4, right? And if I factor that out, that is where this greatest common factor concept comes from. And then I have 4x squared plus the 8x, right? They both have an x, right? I take the smallest exponent, which would be x to the 1. So now I'm going to go back through, like we learned in our review lesson, and I'm going to divide out that 4x, right? So 4x squared, this 4x squared divided by 4x is just x, right? Because 4 divided by 4 is 1. X squared divided by x is x. And then plus 8x divided by 4x is just 2. Right, so that gives me the factored form there. Trinomial factoring, so we have a trinomial, 3 terms. Trinomial factoring is typically where we're going back to Algebra 1, looking for what can we multiply to the 20, that C term here, but adds to positive 9. Right, so we're looking for factors of 20, right? 1 times 20, 2 times 10, 4 times 5, right? That's how I can make 20. Which of those add to 9, which would be these two here, right? So 5 and 4. When I do that then, right, I set up 2 binomials. So I would have the x times x makes x squared, and then plus 5 and plus 4, right? And those come from right here, because 5 times 4 gives me the 20 that I need, and then 5 plus 4 gives me this 9 that I need for right here. The last one, difference of squares. Nobody really likes difference of squares, but it has this a squared minus b squared. So you have to have 2 perfect squares being subtracted. And when that happens, you can say a plus b times a minus b. So here in our example, I have x squared minus 36. I see that x squared is a perfect square and 36 is a perfect square, right? So I can say that this is the same as x squared minus 6 squared, right? So this is my a, and this is my b, right? So x is equal to a, and 6 is equal to b. Probably should have written those the other way. But I can then substitute in here. So I know that I have a plus b, which I know is x plus 6, times a minus b, which is x minus 6. So it's recognizing that you have 2 perfect squares being subtracted, and that is only going to work when you have no middle term, right? I don't have a b term, so I don't have an x in the middle, right, like I did in that trinomial. So let's practice some factoring here. I'm going to use some trinomial factoring here for a. So that is where I am looking for what multiplies to 25 but adds to 10, right? What multiplies to 25 and adds to 10. Well, my factors for 25 are 1 and 25. They don't add to 10, right? I can go 5 times 5. Those do add to 10, right? So my factoring here is going to take on this form, x plus 5, right? Because x times x gives me x squared, and then these go here, right? That's where those 5s came from. So that is my trinomial factoring. B is going to be a greatest common factor. I don't have a C term, right? Nothing without a variable at the end. So I'm going to look at 12 and 27 and what is their greatest common factor, right? Well, 12 is 3 times 4, which is 2 times 2, right? 27 is 3 times 9, and 9 is 3 times 3. So they both contain a 3, right? So they have a greatest common factor of 3, and they both have an n component, right? They both have an n, so I take the smallest exponent. So 12n squared divided by the 3n greatest common factor would be 4n, and then negative 27 divided by 3 is negative 9, and n divided by n is 1, so it's just going to be 4n minus 9. In C, I notice there's no middle term, right? There's no y to the first in this problem. So I'm going to check to see if both of these remaining terms are perfect squares, right? So 9y squared is the same as 3y times 3y. So 3y, and then square both of those. And then the 4 is the same as 2 squared, right? So I can use that a squared minus b squared format. I know that my a value is equal to 3y. And my b value is equal to 2. So then I am going to use that a plus b, 3y plus 2, times a minus b, 3y minus 2. So there is my factored form for those. So factoring is fine, but now we need to move into solving, right? So to do that, we are going to use the zero product property. This is a big algebra concept that is super important. If A times B is equal to 0, we know that one of 3 things has to have happened, right? If you have a product, an answer to a multiplication problem that is 0, the only way you can get there is if A is equal to 0, B is equal to 0, or A and B are both equal to 0. Right? That's the only way you can multiply and get a 0 product. So, looking at example 2, if we are trying to solve a quadratic, this is a factored quadratic, okay? It was used trinomial factoring. If I know that is equal to 0, I know that this part right here has to equal 0, or this part right here has to equal 0, or they are both going to equal 0. So to solve that, I am going to separate these out into 2 problems, right? I know that x plus 3 has to equal 0, or x minus 5 has to equal 0. And then I'm just going to solve these 2 small equations. right? So I'm going to add this 5 across, right? So x equals 5. Over here, I know if I subtract this 3 across, x equals -3, right? So those are my two solutions. I know that because of this zero product property, right? If a times b equals 0, so here I had these two binomials multiplied together equals 0, then the a part equals 0, the b part equals 0, or they both equal 0. So using that, we are going to solve these quadratics. So for example 3a, I am going to use trinomial factoring. You may not need to be this show this step, right? But what multiplies to make -20, but adds to make -1, right? Because there's an invisible 1 right there. So I know that -5 and +4 multiply. -5 times 4 is -20. -5 plus 4 is -1. So I know my factored form is going to look like this. Okay, this is a 4. And these have to equal 0, right? So now I'm going to split. X minus 5 equals 0, or x plus 4 equals 0. So when I solve these out, I have x equals 5 and x equals -4. Same thing here. I have no c term, right? I have no plus or minus at the end that doesn't contain a variable. So I'm going to use greatest common factor, and they both can factor out a c. Right? So I get c times the quantity c minus 5 equals 0. So I'm going to split this. I know that c has to equal 0, or c minus 5 has to equal 0. And then I solve this one, right? Add away the 5. So there's my solution. For c, this is difference of squares, right? A equals x, b equals 5, right? So I can sub that into the x, or a minus b times a plus b and these have to equal 0. So then I can say x plus 5 equals 0, or x minus 5 equals 0. And then I work to solve those out, right? So I solve this little equation, and I solve this little equation. So I know x is equal to plus or minus 5. Right, so that's a review of factoring, solving quadratics by factoring from Algebra 1. And get your worksheet completed, please.